So let's go through the problems we went through in class today and see what we can come up with here and get you the correct answers, okay? So if we zoom in a little bit better here, we have a singlet there, a quartet, a singlet, and a triplet. Can't see it very well, but that's C5H80, I believe. So when we look at this here, what can we just take off the table right away? Is there anything? 1, 2, 3, 4, 5. Well, the answer here in this particular problem, as you can see, is G. And what we can do here, let me show you how we would label it. That's A, B, C, and D. So that proton is A. And then we have 6 that two singlets here. That would be C and C. That's a singlet. And then this would have to be B, because that's going to be split into a quartet. And then D would be split into a triplet. And the integration values all make sense. And that's the answer. So G. Right there. Okay. So in this particular one, I'm just worried that you can, because you didn't have the tables with you, so this would have been really difficult if you didn't focus a little bit of time memorizing those tables. So I'm just going to grade this on if you were able to identify how many signals there are for a carbon-13. So there's one. Well, let's do, maybe we can color code it. Oops. Let's do a color. There's 1, 2, 3, because those are equivalent. 4, 5, 6, 7, 8, and 9. So we would expect those to be 9 signals. So everything that's the same color, those two, so for example, that red one and that red one, those are equivalent to one another, and those two carbons would only give us 1 signal. And so, but to answer all the other questions, you can see there's the answer right there. And I think that was the last one. Nope. 27. Okay. So we see that the answer is E. But how do we get answer E here? Let's see. So that's A, and A. Those are all the same things right there. Let's go, that's a quat carbon. C, D, E, and F. So that's how many signals we would expect. So A through F, what's that? A, B, C, D, E, F, 6 signals. Do we have 6 signals? 1, 2, 3, 4, 5, 6. So that matches. Okay. That is just the solvent, so we totally ignore that. TMS, we totally ignore as well. So we just have 6 signals. And so if we did that, we could, off the table, just get rid of this guy, because there's more than 6 carbons that are going to give separate signals. Same with that one, same with that one, same with that one. That's off the table. And then when we look at F, there's A, B, C, D, E, F, G. So that's off the table. And then this one right here. So that's A. Ooh, that one's going to be a little tricky. B, C, D, E, F, G. That's another one that just gives us 7 signals instead. Okay, let's see. I want to see one other thing here. So like if you labeled these carbons, where would they be here? That's E because it's further downfilled. Okay. And then that would have to be C because it's a quat carbon, really far downfilled. This one is B, it's a quat carbon, but it's upfill. Then we have A. There's our methyls right there. And now between D and F, let's see here. Well, maybe A. Yeah, so what would we say for those last 3 methyls groups? How would we identify those? So I'm going to open the table. I'm going to open my book real quick just to confirm a few things of the chemical shifts of those different types of carbons there. I know that the question didn't ask you to rank or annotate it, but I just want to double check. And the table's not showing much detail on this type of molecule here. You know, instead of spreading some misinformation on this is where I'm just going to leave it. And if you want to delve deeper into it and try to identify, identify and annotate those, I'll come back to that because I want to double check something before I post this, okay? But you saw my analysis though, how I eliminated all the other answer choices, right? Because they would all have too many signals. Except D. How many signals would D have? 1, 2, 3, and then 4. So that one would only have 4 signals. You can clearly see that there's more than that. Okay. Now I think that was the last one in this section here. Yes. So let's go to chapter 16. Which one was the first problem in that one? Number 2. Okay, this is just a simple definition. You can see that these are isolated double bonds because there's no double, single, double. Question 4. The next one. Okay, in structure 1, we have conjugated double bonds. And then in structure 2, we have isolated. Okay, so this carbon right there is sp3 hybridized, whereas all these carbons right here are sp2 hybridized. So this bond length, we would expect to have the same bond length as this guy, but when we delve into it and actually take out the measuring tape and measure it, we see that in structure 1, that bond angle, or that bond, is going to be actually shorter than what we would expect. Why? Because we can draw a resonance structure that looks like this. We could take those electrons and go like that. You have a resonance structure like that. And so now you can see that this orange bond right here now has double bond character. So it's going to be shorter than what we would expect. So how did they say the correct answer is? Yeah, that would also say the same thing. Question 5. We kind of went over this mechanism a little bit in class, just with a different example here. But if we have our bromine like this, our first step would be to come and grab that. Then one of the lone pairs would come in and kick that guy off like so. And then we would look like this. I'm going to go BR. I'm not going to show stereochemistry in this one, just so we can see that. Plus our BR minus, like so. And then we have lone pairs there. Come in. Go like that. And so we would have a BR there and then a BR there with this double bond still there. Just like that. So that's our 1,2 product. What is the correct answer choice? Is that what we have? It should be B. Question 9 is the next one. Oh, I didn't do that one. Okay, question 9. This is a Diels-Alder reaction. What we can notice, though, is the electron withdrawing groups on the dienophile, they're trans to one another. So they have to be trans in the product. So those are cis, so that means that one's off the table. Those are cis, off the table. So now we're only left with C and D as our... We can see that the electron withdrawing groups are in the right spot. And now if we just draw our mechanism here, like this, hopefully you guys can see. I'm just going to go E for electron withdrawing group to keep it simple. That's going to come in and attack that carbon. Those will go there, go like that. And so what bonds are we forming? Between that carbon and that carbon, and that carbon and that carbon. Like that. So we can't forget about those 2 carbons right there. So we can draw it like this if we'd like. I like drawing it like that. And so if I remember that carbon 1 is carbon 2, that's carbon 1 and carbon 2. And that's carbon 3, okay? So we have the O methyl. That's going to be sticking down. O methyl like that. And then we have in orange, those 2 carbons right there. Like that. And then we are going to have these trans to one another. So one of them is going to be up and one of them is going to be down. Like that. So the only possible answer choice would have to be C. So I'm drawing how it would look like that. So both would be correct answers, and I would expect you guys to be able to draw both of those and recognize that. Okay, let's see. I believe that's all we went over in class. So I hope you find that helpful, and if you have any questions, please reach out. I'd be happy to help.